Hi everyone, welcome back. In this video, we're going to learn about our first data structures called arrays. Thus far, we've learned about primitive types as well as individual variables, but the problem with those is that they can only ever be one value at a time. This poses challenges if we need to work with many values at the same time. So we have arrays. Python technically does not have a built-in array data type, but the equivalent in Python is lists. Universally across many programming languages, an array is denoted with the square brackets. Go ahead and pop into the Python REPL and then type what I'm typing. I'm going to create a variable words and set it equal to open square bracket, and inside these square brackets you can specify a list of values separated by comma. I'm going to go ahead and pop in a bunch of words or strings here. Hello, this is a list. And now the words variable we've just created, it behaves just like variables we've created in the past. The only difference is that now there are many values in there, not just one. If you just print out the words variable as is, it prints out all of the values and in this exact format. Then if I pass words into the len function, it'll tell me how many values I have in this list. So this is great and everything, but what if I want to access just an individual element? Well, you can do so via its index. The index just indicates an element or a value's position in line. You can almost think of it like it's a ranking of sorts. So if I type words with 1 in square brackets, it gives me this, and if I type words of 0, it gives me hello. Now you may be just a little confused. Why is hello index 0 and not index 1? Well, that's because in programming we use what's called zero-based indexing. Now, the following piece of information you don't need to know or memorize. You would learn this if you chose the backend or systems path in the academy. But at a high level, in the computer, all of this information is stored in individual slots. What happens is that the words variable is just pointing at this first slot, which contains the word hello. And then every element after the first one is accessed via an offset to the very first element, so words plus 1 or 2. If that didn't totally make sense to you, that's okay. Let's just go ahead and move on for now. So what happens if I try to access an index that doesn't exist? For example, we know that this list is only 5 elements, meaning the highest index is 4. What happens if I do words 7? Well, you get an exception, right? Your program will crash. By the way, another word you should know about, exception. For now, you can think of it as being interchangeable with the word error. It basically means something bad happened. You can change any of these values in the list at any given time. If I print out all these elements again, remember that words 1 is this, right? What I can actually do is words 1 is equal to that. And what I've just done here is I've reassigned whatever is at position 1 in this list here to whatever I assigned it to. And now if I print out my words list, you'll see hello, that is a list. For the rest of this course, I'm just going to refer to them as lists. However, do not forget the arrays terminology because the word array is universal across many different languages. Everyone will know what you're talking about when you say array. However, list can mean different things in different languages, so keep that in mind. Anyhow, let's continue. Really quickly, let's go ahead and create an empty list. You can do so by typing equals to empty square brackets. This creates an empty list here, and now let's start adding elements to it. The first way you can add elements to a list is by using the append method. So if you call the name of your list variable, type append followed by parentheses, and then whatever you put inside that parentheses, that's the thing you want to insert into the list. I'm just going to go ahead and keep inserting more numbers into here. 2, 3, let's skip a number, 5, and then 6. There you go. And by the way, to do this more quickly, remember you can hit the up button to get the previous command that you typed. So now if I print out my empty list, you get 1, 2, 3, 5, 6. And actually, empty list is kind of confusing now. I'm going to go ahead and rename it to my list. There you go. And now if you print my list, you can see 1, 2, 3, 5, and 6 into here. All right, so again, append adds items to a list, but notice how all the items in the list are in the exact same order that I appended them in. That's because the append method adds them on to the very end. There's another way to insert items into the list, and that's using the insert method. Now, if you look at our list, you can see that the number 4 is missing, right? Let's go ahead and insert number 4 into the list now. The insert method takes 2 arguments. The first argument is going to be the index that you want to insert the element at. The second argument is going to be the actual element. Now remember, lists or arrays are zero-based. So if you want to insert this element at the 4th position, it's actually going to be index 3. I want to insert the element 4 at index 3. And now if you print out my list again, you can see 1, 2, 3, 4, 5, 6. Now here's an interesting thing. Let's go ahead and type empty list again. You can see here that empty list is also modified to have the 4. Well, that's because when you set another variable, a new variable name equal to a currently existing list, that actually creates a new variable or a new pointer to the same list in memory. In contrast, if I try to do this with just regular primitive variables, right? Let's set num equal to 5 and let's set other equal to num. If I print out other, it's equal to 5, but if I increment num by 1, num is now 6, but other is still 5. And so, generally speaking, primitive variables, when you create a new variable and you set it equal to another primitive, that actually creates a copy of that variable. On the other hand, with data structures like lists, etc., when you create a new variable and you set it equal to a list, you are actually pointing at the same list in memory. Anyhow, let's continue. I'm going to clear my screen. If you remember the keyboard shortcut for that, that's Control L. I'm going to really quickly create 2 new lists here. One is going to be letters 1, set it equal to A, B, and C elements. Then I'm going to create a letters 2 and set it equal to D, E, and F. Now, check this out. If I do letters 1 plus letters 2, oh, sorry, that's not supposed to be a space there. There you go. You can see here that I get a brand new list with all of the elements of 1 and 2. Kind of cool, right? And so if I create a new variable called total and I set it equal to letters 1 plus letters 2, gosh dang it. Okay, total is equal to letters 1 plus letters 2. Now the total variable has all of the letters in it, right? And so you can see that the plus operator yields some kind of output or result. And this output or result is a copy. It doesn't directly modify letters 1 or letters 2. Now, check this out. If I do, however, letters 1.extend letters 2, this .extend method takes another list as an argument, and it directly modifies the list that calls that method. So if I do letters 1.extend letters 2, you can see that letters 1 is now A, B, C, D, E, F. It directly modified itself. If I want to remove elements from a list, I can do letters 1.remove. Remove takes an argument, and that's just going to be the element that you want to remove from the list. So if I remove D, then you can see that letters 1 now only has A, B, C, E, F. Another way that you can remove an element from a list is by using the pop method. However, unlike remove, which takes the actual element itself, the pop method takes an index. So if I say pop 3, it removes whichever element is at the 3rd index of the list, which is going to be E in this case because I already removed D. And so now if I print letters 1 again, it's only A, B, C, F. The last way you can remove an element from a list is by using the del keyword, short for delete. If I do del letters of 3 again, now you can see that it removed the F. Alright, and now we come to the last part. You know a lot about lists already. You know how to create them, you know how to add elements and remove elements from them, you know how to modify elements, you even know how to add lists to each other. Now let's just talk about generally working with lists and iterating through the elements so that you can solve problems. Now, to start with, I want to create a large array of strings. And there's actually a kind of a neat way to do this that I'm going to show you. I'm going to create a new variable called sentence, and then I'm going to make a string, basically. I'm just going to type, and now, here's the cool part. Create another variable for your list here. I'm going to call mine R, ARR, and I'm just going to set it equal to sentence.split. And then if you print your variable, you can see that it is a list consisting of all the words from the string you just split. The split method automatically splits up a string based on some kind of token, or another word for it is delimiter, that you specify. And if you don't specify anything, then by default it just uses white space. If you've never heard the term before, white space just refers to any kind of space in the string, and so that's going to be your regular spaces, that's going to be tabs, new lines, etc. Now, lists are iterables. If you remember our lessons from last section about iterables, you know that you can loop through them. So we can go ahead and do for word in R, go ahead and print word. And then you'll get a nice line-by-line printing of every single item that's inside that array or list. But this only gives you the element itself. If you need the index as well as the element, you can do something else. For index, comma, word in enumerate of R. The enumerate function basically returns tuples of data. In other words, it returns multiple pieces of data at the same time, and now you have access to both the index and the value. Just to demonstrate this, I am going to print format index and word. And you can see that I am now using both the index and the element inside my loop. And that concludes the basic lesson about lists. There's a whole lot more to learn about lists still, but this is enough for now just to work with them at a basic level. Let's go ahead and solve a couple example problems with lists.